Greetings, everyone. This is Mr. Keister with you again. This is the video for Thursday, August 13th, which is our scheduled third day of school for the fall semester. Again, I am doing these videos for you for two reasons. Number one, in case we are not in class due to COVID-19 or any other reason, that we can continue on with the day's work. And number two, if we are in school and yet you are absent due to COVID-19 or other reasons, or you are quarantined or whatever, or I am quarantined, then again, we can continue on with our daily work as normally scheduled. So, as I look back at the board here, this is our schedule, or what we call our do nows, for today. Now, this is for Chem 2. I will bring up the Honors Chem 1 here in just a second. They're almost identical and have been thus far in the beginning of the school year, but they're going to branch off here fairly soon, and I'll be doing separate videos for Chem 2 and Honors Chem. But at least for today, we can still pretty much run concurrently together. Like I said, this is for Chem 2. I will put the Honors Chem schedule up here momentarily. So you were to pick up three papers today, pages 10, 11, and 12, which again I have the running list on either side of me here on the chalkboard. Yesterday we did, you picked up the lab equipment study sheet, worksheet, and lab equipment names and definitions, which were pages 7, 8, and 9. Your homework from yesterday, and this again applies to both classes, was the lab safety study sheet, which I went over in class, and the lab equipment worksheet. Okay, you were to do that. Hang on to both of those. Check your answers if you need to. They're posted on the back board. I explained that yesterday, and again, if we're by chance not in school, and since you wouldn't be able to check your answers in person here on the board, then I will send you those answer key documents which you would be able to access from campus. Today in class, I'm going to be doing a lab equipment practice quiz. The real quiz will be this coming Monday in Canvas. See number 5 below. I'm going to skip number 4 for just a second because again, that's really the only one that's a little bit different for honors. Everything else is the same. So I'm going to skip down here to number 5. There will be both a lab safety quiz based on that lab safety study sheet we went over yesterday, and a lab equipment quiz based on the practice quiz that we go over today and the worksheet that you should have completed. Both of those quizzes will be in Canvas, and they will be given on Monday, all right? Monday, which would be the 17th of August. And again, whether we're in school or not, since this is a Canvas quiz, you'll be taking it either here in the classroom on Canvas, or you'll be taking it at home. So either way, nothing changes. So for Chem 2, your homework for tomorrow, using your Unit 1 notes packet. Okay, so I mentioned this a little bit the other day. With each unit, you are going to receive a notes packet. This is something that I've accumulated over the years, again, from various chemistry textbooks, nearly all of them college chemistry textbooks. Basically, what I've done is shrunk down the information and all the pages you would have to read in a textbook to what we absolutely need to know. So it's kind of a condensed version of your textbook, and it takes away the need for having to assign you reading out of the textbook, all right? So this is your go-to document for each and every unit, all right? The notes will be taken on this notes packet. There'll be additional things for you to write down as I write them on the board. But a majority of them, as you can see, are already pre-printed for you. That saves us all a ton of time, okay? Also, all the assignments that you'll be doing with each unit, as well as the labs and the quizzes and the tests for each unit. If there is a quiz, I don't give a quiz all the time. But all of those assessments come off of these note packets. So these are extremely important. All right, extremely important. All right. Anyway, using this notes packet, you're going to complete the assignment, which for Chem 2 is the basic terminology review assignment. All right. You'll be able to answer all those questions from the note packet. I do my very best to order the questions in the order that you would read that material in the notes packet. Sometimes I might be off a little bit, but most of the time it should be in order. All right. So at the beginning of each unit, you're basically going to get a new notes packet and an assignment similar to that. Here's the reason for that. And again, I haven't done any lecturing yet over this material. That will be coming soon. But here's the deal. I want you to complete the assignment before the lecture. All right. So in other words, this forces you to not only read the notes packet, but to write down questions that are asked about the notes packet, which gives you then an idea of what we're going to be doing in that unit. So it serves several purposes, several important purposes. Because I know, honestly, I mean, really, if I say, well, if I was a textbook kind of guy, I'd say, okay, so our upcoming unit is pages, 15 to 40 in the textbook. Make sure you read those before class. Now, how many of you are going to do it? Yeah, probably very few, as I probably wouldn't either, or would just skim it at best. So again, textbook. So the notes packet, though, again, like I said, is a much condensed down version of the text. And by giving you an assignment, it forces you to read through this and answer some questions so that you have a good idea of what's coming. All right. So again, it's got I had several things in mind when doing this. All right. And it's all to benefit you. Okay. Anyway, that assignment is due tomorrow at the beginning of class. All right. At the beginning of class. And again, I would have the answer key posted by 7 a.m. So if you want to come in and check your answers before your actual class period, that is certainly okay by me. Now, let me bring up the honors schedule real quick. It looks very, very similar to Chem 2. Again, we're kind of running together here the first couple of days of school before we separate ourselves. And as you can see, you're also picking up 3 papers. The lab equipment practice quiz is exactly the same as the one at Chem 2. Your notes packet and your assignment, though, are a little bit different. All right. So this is the notes packet for Honors Chem. Everything that I just said in regard to Chem 2 and the notes packet applies to you. And here is your assignment here, Unit 1, Assignment 1 over matter. And that will be due again tomorrow. It's right here under number 4. That will be due at the beginning of class tomorrow. And I will be collecting it for a grade in both classes, if I failed to say that before. So, and again, just like Chem 2, number 5 applies to you guys as well. You'll be having a quiz, 2 quizzes in Canvas this coming Monday, the 17th, over the lab safety and lab equipment. So, having said all that, let's go on to today's activity, which is I'm going to go over the lab equipment with you. So, you'll want to have your lab equipment sheets out from yesterday. This is one of them, the lab equipment study sheet. This had pictures of all the pieces of equipment that you could identify with the live pieces of equipment that were here in the classroom. Again, if we weren't in class or aren't in class, then you would have to strictly go by the pictures. And I'm going to show you the live versions today on our practice quiz. There's more on the back. And then you had a lab equipment worksheet to fill out, okay, for each of those. with the names of each piece of equipment based on the number that was on this picture sheet here. And then also you had a list of uses here that you were to write down what each of those pieces of equipment is used for. So have those nearby. Have the practice quiz sheet that you picked up today with you, and we're going to go through that right now. So here's how this is going to work. So here's the practice quiz. So here's how this is going to work. What I'm going to do is show you a piece of equipment. I'll say this is number one, and then you were to write down what its name is. You'll have that list next to you, so you choose from the list of names, and then you'll write down what it's used for. You would choose that from the list of uses. We're only going to be using each of them one time, so as you go through, you can scratch them out or mark them out or however you want to do it. All right? Okay, well, here we go. So, number one. This is number one. Okay? Hopefully you would recognize that. I'm not going to spend a whole lot of time waiting on you to write down. Of course, you can pause this video while you're writing. That's perfectly okay. Anyway, number one, this is a funnel. All right. It is used with filter paper to filter mixtures or used to transfer liquids. All right. So if we're filtering something, we would put a piece of filter paper in there and pour the mixture in. It would catch the solid type materials in the filter paper. It would, the filter paper is porous. It would allow the liquid portion of the mixture to run on through. We would have a beaker or some other type of container beneath this, and in order to catch that. All right, so it separates the components of the mixture for us. Okay. Number two. I think we all know what these are. All right. Of course, these are safety goggles or just goggles, and these are used for eye protection. Right? They protect the eyes when heating or working with chemicals. So this is how we wear the goggles. All right, like this. We don't wear them like that. I'm not all that interested in protecting your forehead, and we don't wear them like that either because I'm not all that interested in protecting your neck. All right, it's the eyes that are the important thing here. And so that's what they're used for. All right, number three. This is number three. Okay. This is called an Erlenmeyer flask. Right? That's actually named for a guy that developed it. This is a reaction vessel in which you can swirl liquids, and as you can see, it's got a narrow mouth, and it can be stoppered, which is kind of handy so you don't have stuff spill out of it. So it's a reaction vessel. We run reactions in it. You can also heat things up in it, things like that. Now, you'll notice on here that there are numbers on there, and those are volume measurements. Do we use an Erlenmeyer flask to measure volume? Well, according to this use, I don't see anything in there about that. And the answer is no. Now, you could use this to approximate volume, all right, but certainly not to measure volume. In fact, yes, right here, it says plus or minus 5%. So what that means is, the actual volume could be 5% higher or lower than what you read it, depending on how you read it. So these will give you an approximate volume, but we absolutely do not use them to measure volume. Okay, so this is an Erlenmeyer flask. Number four. This is number four. Probably you all recognize this. You've seen them before, used them before. This is a beaker, of course. This is just one of many different sizes that we have. This is a 250 ml beaker. It is also a reaction vessel. All right, so basically a beaker and an Erlenmeyer flask can be used essentially for the same things. However, as you can see from its shape, the beaker has a much wider mouth, all right? And as such, swirling liquids in it is not a good idea because they're going to come splashing out the top fairly easily. And you also cannot stopper one of these. Notice it's got a little spout there to pour liquids out of, which is pretty handy, but it makes it pretty much impossible to stop it. So so it and an Erlenmeyer flask are basically used for the same thing, just in different scenarios. Okay. Again, this also has volume measurements on it, but here again, there's no mention of volume measuring as a use for this piece of equipment, and indeed, we do not use it to measure volume. You can use it to approximate volume. If it says you need approximately 20 mLs of something, then you could use a beaker. But if you're measuring exactly, no way. Okay. Number 5. I have 2 examples of number 5. These are dropper pipettes, or just pipettes. Now, these are used to transfer small amounts of liquid. Now, these we use a lot. All right, these are freestanding pipettes. All right, you'll find these at your lab table in a lot of labs that we do when we're transferring liquids. A pipette, again, you squeeze the bulb. I mentioned this with the lab safety the other day. You squeeze the bulb, place it in the liquid, release the bulb. It will change in pressure in there that will draw liquid up into it, just like when you suck on a straw. And then you transfer it to another container or whatever and depress the bulb and out it comes. All right. The difference between this one, like I said, this is a freestanding pipette, and this one would be part of a bottle. All right. We have some of our liquids are in bottles that have lids that have a dropper pipette as part of the lid. So you'll see these on occasion as well. All right. So a dropper pipette used to transfer small amounts of liquids. Number 6, this is a spatula, right? Doesn't look like the spatula you have at home to fry eggs with or to turn a hamburger on a grill, but it is a spatula, all right? So the spatula is used to transfer solid chemicals. Now, one thing I want you to notice is the spatula has 2 ends you can use. This end down here is more rounded, kind of like a spoon, and much wider. On the other end is flat, and it's also much narrower. So, well, when do you use which one? 9 times out of 10, I'm using the spoony type end. All right, you can transfer more chemical that way, and usually, so like if I was going to spoon something into a beaker, I could just scoop that into the chemical and so on and so forth, and there you go. So what's the narrow end for? Well, let me show you. Here we go. Haven't got to this yet, but you probably know what it is. Now, if I was going to transfer some solid chemicals into this, and I use the spoony end, all right, so I got a chemical here, and it's like, uh-oh. And so what happens when you try and pour that in there? Well, half of it goes down the side, and you miss, all right, so not a good idea. But if you use the narrow end, right? Use the narrow end, and you say just tip this thing over a little bit, and you could just put that right in there, and then tilt it up and do that, and you haven't spilled anything. All right. So really, this narrow end is to transfer solid chemicals into a test tube or something that's got a narrow opening. All right. Other than that, like I said, 9 times out of 10, you'll be using the bigger end. Okay. Number 7. This is a big one. All right. This piece of equipment right here is called a burette. All right, a burette. There we go. See the bottom of it there. Okay. It's got a little valve on it that right now it would be wide open. You'd be letting liquid out of here. Turn it horizontally, and that stops it. All right, so it's like a shutoff valve. A burette is used to dispense a specific volume of liquid. So I don't know if you can see very well on here, but there are volume numbers and little markings. We call those graduations. All right. And based on the size of or the distance space of those markings, we know what amount of volume it's what it represents. And so anyway, we also use a graduated cylinder to measure volume, and this is a very similar. Let me grab one here. So here's a graduated cylinder. We haven't got to that, but it's coming soon. Well, they're very similar in appearance. Right? They're cylindrical, obviously. They both involve measuring volume. Okay. The difference is this. So in a graduated cylinder, sorry, my nose is itching. In a graduated cylinder, you both pour liquid in and pour liquid out from the top. All right. That's it. So the volume starts at the bottom. This, of course, is empty, 0, and as you fill it up, you go up higher. This is a 100 ml graduated cylinder. A burette, you pour liquid in from the top, but you release it from the bottom. And when you want to release a specific volume of liquid, which is what you use a burette for, then this is what you want to use. Now, if you had this full and I say, okay, pour 10 mLs out of this graduated cylinder into another container, into a beaker or whatever, and you try doing that, so you start at 100, you want to go to 90, and it's like, no, too much, all right? Doesn't work well at all. But you fill this up, and you want to release 10 mLs. So we have another beaker or Erlenmeyer flask down here, and we look up here and we release it, and it goes down, 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 and when you get to 10, boom, shut it off. Easy peasy, all right? So the numbers on a burette, the volume measurement numbers, are reversed, all right? So 0 is at the top, and this is a 50 ml, I believe. Oh, no, this is 100 ml, so these hold the same volume. When you want to release 10 mLs, the 0's at the top. When you get to 10, cut it off, all right? So the numbers are in reverse order. That's because you're releasing it from the top down to the bottom, okay? So this is a burette. It is used to dispense a specific volume of liquid. We'll hit graduated cylinder here in a little bit. Number 8 is a stirring rod. This is not a tough one. Okay, it's a little glass, made of glass, and what it's used for is exactly what its name implies it's used for, and that is for stirring. Right? Right. Number 9. I'll bet you've seen one of these before. Okay. So this is a mortar and pestle. Mortar and pestle. It is used for grinding solids, right, into smaller pieces. This is probably one of the oldest known pieces of chemistry equipment. This has been around in some form or fashion for a long, long time. All right. So a mortar and pestle is used for grinding solids. Now, do you know which one's? It's a mortar and pestle. You know which one's which? Any idea? The bowl is the mortar, and what looks like a pistol, in fact, this looks more like a pistol than this does, is the pestle. So the pestle does the grinding, all right, and the mortar holds it. Okay, so mortar and pestle, grinding solids. Next, test tube brush. So this is number 10, test tube brush. As you might guess, this is used to clean a test tube. All right. Number 11. Well, I'm going to do 11 and 12 kind of together. All right. This is number 11. There you go. This is a test tube holder, and number 12, of course, is a test tube. So the thing with test tubes, and the need for a test tube holder is this. If you're just pouring a liquid or a solid chemical with a spatula like we just showed into here, you're probably not going to need this. But if you're heating something in this, you are absolutely going to need a test tube holder. So number 11 is a test tube holder used to hold a test tube. Number 12, the test tube is used for mixing or heating chemicals. When you get to the heating part, that's when you want to use a test tube holder. Now, I mentioned this yesterday. Whenever you heat something over a Bunsen burner in a test tube, and I'm going to show you this when we get to our first lab again as well. I'll remind you of this anyway. You always point the test tube away from everybody, and you don't hold it straight up and down. You hold it at about a 45-degree angle, and you place it in the Bunsen burner flame at the very tip of the cone, and I'll explain that when I fire up a Bunsen burner in our first lab. Okay, but this is how you would hold it. And again, now people get a little confused by this test tube holder the first time they use it. Notice if you depress the handle, that's when it lets go. All right, and so it's when you let go of the handle that it locks in. So kind of backwards, really. So you don't want to pick this thing up and then press in like you would a pair of pliers. It works the opposite way. All right. So when you press in on them, it lets it go. It doesn't clamp down on it higher, tighter. That is. Okay. So that was 11 and 12. 13 we've already talked about. This is a graduated cylinder. Right. Graduated cylinder. This is used to measure volume. Right. This is used to measure volume. And again, like on a burette, the individual little lines on here are called graduations. That's why it's called a graduated cylinder. And those then allow us to get an accurate measurement. Now, let me draw a quick picture of the graduated cylinder here. So here we go. All right, so let's say this is 25 mLs and this is 24. All right. Well, and we put a liquid in here, whether it be water or some other liquid, and it goes like, about like that. You probably noticed this before because I'm sure you've used a graduated cylinder before, but that liquid does not lay in a graduated cylinder flat, right? It curves down like so, okay? Anybody know what that's called or remember what that's called? If you said meniscus, you're right. All right. Meniscuses, not sure. They form in a rounded cylindrical container because of surface tension. And we'll get into that later. All right. And the force of gravity, those two. All right. And so, how do you remember or do you recall how to read a volume with the meniscus? You read underneath it, like so. So at the base of the meniscus is where you read the volume measurement. Okay? All right. So, graduated cylinder. Number 14 is an electronic balance. We have several types. This is one of them. Electronic balances are great. Right? They're used to measure mass, right? Not weight, mass. And back in the old days, when we didn't have electronic balances, we had the old triple beam balance. You've probably seen one of those. You know, you put your stuff over here, and then you got slide bars here, 2 or 3 different ones. And, you know, you're going back and forth, and it's going, and, yeah, it took 5 minutes to find the mass of something. And here it takes about, 2 seconds, maybe 3 seconds at most. So love the electronic balance. It measures mass. Number 15, this is a thermometer. It's not the standard one we used to have. We used to use, the long glass ones. But again, these are electronic. These are just a digital thermometer. And I just turned it on, and you can see maybe right there. Looks like it says it's 22.2 degrees Celsius in here, which is around 70-ish, 72, 73 degrees Fahrenheit. All right. So this is a digital thermometer used to measure temperature. 16 is a striker. All right. So this is a standard striker here. Can you see that? Is it even sparking? Not very well. I need to replace the flint on there. I don't like these things. They're really kind of unreliable. So I've gotten these from Walmart or the dollar store or whatever. They're pretty, pretty reliable until they run out of butane, of course. But the purpose for a striker or this lighter is the same, and that is to ignite a flame. We use them to light a Bunsen burner. Okay. Which brings us to the next one, which is a Bunsen burner. It's right here. Right. This here is the Bunsen burner. This, of course, is the hose that connects it to the gas jet on your lab table. Right. I will talk to you about lighting these and how to adjust them properly in our first lab. So the Bunsen burner is a flame. All right. Obviously, using supplied gas, we use methane gas or what's called natural gas, and it's used, of course, for heating. Okay. Number 18. These are crucible tongs. Okay, crucible tongs. They look like tongs, but kind of weird looking. They're curved on one end, and they have a little opening there in the middle. Crucible tongs are used to pick up a crucible. Right? Pick up a crucible. And he said, okay, well, what's that? Well, that's what we're getting to in number 19. I'm going to keep the tongs out and show you how to use them here in a second. So here is a crucible and lid. Right? Crucible and lid. This is used to heat small amounts of solid, obviously small amounts, it's very small, to a very high temperature. All right. Now, as we said before, you can certainly heat a small amount of solid in a test tube. You can. However, something that's got a pretty high melting point, all right, I would not be heating in a test tube because the test tube is made of glass. You expose that to a 700-800 degree flame for very long, a significantly longer period of time, the glass is going to break. All right. Not going to happen with a crucible. This is made of a heat treated ceramic material, right? And you can use it to heat things way beyond what you could in a glass container, right, without the fear of it breaking. So these are used for high temperature heating, okay, of solid substances. Now let's talk about how you would use the crucible tongs. So I'm going to put something together here that we haven't got to these yet, but that's okay. So the crucible would be sitting in here like so. Underneath would be the Bunsen burner, and we'd be heating up whatever solids in there. Okay, so when you, obviously this thing is going to be extremely hot, right, when you're done heating or melting the solid that's in there, okay? Here's where the crucible tongs come in. Now, there are two ways you can use them. If you want to pick up the crucible and the lid at one time, you're going to turn these around so that the pointy end is pointed up, all right? You're going to open them up wide, like so, and get beyond the lid, and then you'll bring them together, like so. Pick up the crucible and set it down here, either on the base of this thing here or on a wire gauze pad to cool. We don't set it directly on the lab tabletop because honestly, those are so hot, it'll start melting the tabletop. All right. So the other way, if you get a little nervous doing it that way, because if you squeeze too tight, that thing starts rocking around like, like so. It's like, uh-oh. So maybe you're not real comfortable doing that because, like I said, what's in there is very hot. If you take your tongs and turn them around the other way where the ends are pointed down, you can simply grab the lid first, fairly easy, set it down, and then you can grab the crucible itself just by grabbing it on any of the edges, anywhere on there, pick it up and set it down as well. So pick it up together this way, pick them up separately this way, probably less likely to drop either of those doing it the second way, but that's up to you. Okay? Now let's set these aside. We'll be getting those back out here in a little bit. Well, here's the next one. Number 20, this clay triangle. You can just see what we used it for. It is used to support a crucible or a funnel. All right? Get this back out. So if I was using it with a funnel, I'd set the funnel in there like so, put my beaker or Erlenmeyer flask underneath it, and do my separation of my mixture there like we talked about before. So a crucible, a clay triangle can be used to support a crucible or a funnel, either one. Okay, backside, number 21. This is a watch glass, all right? Watch glass. You notice it's curved, right? It's curved. This is the concave side. Remember, caves in, convex, concave. All right. So this is used to cover an evaporating dish or a beaker. Now we'll get to the evaporating dish in a second. If you use it to cover a beaker, I don't know if this one's large enough. Yeah, it is. So if I'm heating something in a beaker, I could use this to cover it so it doesn't splatter out. All right, which still would allow the steam or gas to escape from the lip of the beaker. So you could use it for that. Primarily, it's used for the same general purpose to cover an evaporating dish, all right, which we're going to get to next. So this is number 22, an evaporating dish, all right. Remember the crucible? Here's a crucible. Here's an evaporating dish. Notice anything about those two? If you said, well, it looks like they're made out of the same material, you would be exactly right. They are. And remember, a crucible is used for high temperature heating of solids. This, an evaporating dish, as you might guess with that little lip right there, is used for high temperature heating of liquids. So if you're boiling a liquid that's got a pretty high boiling point, which water is one of them, again, you can boil water in a beaker or an Erlenmeyer flask, but you don't want to do it forever because you'll break the glass, right? This, you could heat it much higher for a much longer period of time without worrying about this thing breaking, right? So you can use it, its name is an evaporating dish, so certainly you could use it to evaporate a liquid in as well because it's wide, so you got a large surface area of the liquid exposed to the atmosphere, so it would evaporate quicker than if you had it in a narrower type container. But primarily, it's used for high temperature heating of liquids. Okay, and then the watch glass, the cave side or curved side up, fits on top, just like so. I'll tip it over there. So there again, you see the curve. So there again, when you're heating the liquid, it can heat it to a boil. Obviously, that's probably what you want to do, and you can the steam or gas vapor can escape through there, and the liquid will not boil over. Right, so works out quite well. All right. 23 is a wire gauze. This is a wire gauze, right? A wire gauze is used to spread out the heat from a flame or to place hot objects on to cool. Now, if I was going to heat, here's how I would use it for heating. So again, I would set that right there, put my evaporating dish right there, put the watch glass on after I've got the liquid in there, Bunsen burner under here, heat this up, and it works beautifully. All right, works great. Now you can use crucible tongs to lift up an evaporating dish. This is tricky, folks. You're going to need two hands. Spread that way wide and lift carefully without squeezing the handles together too much. Remembering this is going to be extremely hot. And again, you could set it down to cool. Likely, I would have a second wire gauze sitting on the tabletop here and set that evaporating dish on there to cool. You see it's got this pad, circular pad on it. That's a fire retardant or heat resistant pad that allows the heat to be spread out. So I also used it to heat something up in a beaker. Now the flame is not going directly on the glass, but it's being distributed outward by that pad. And so you could heat something up longer in a beaker, having it sit on a wire gauze, than you could by putting a flame directly under it. Okay? And then that takes us to the last one, number 24, which I've been using several times here. This is a ring stand and a ring clamp. This, of course, is the stand, and this here is the ring clamp. And it is simply used, as you can see, for support. We use it to set things on and to stabilize them so that we can do whatever it is we're going to do with them. All right, so that's a ring stand and a ring clamp used for support. And that takes care of the 24 pieces of equipment that you need to know and be familiar with, because we're going to be using them very often throughout the year. The last two questions, there's two more questions on the quiz that you were to answer. As you were to go about the room and look at all the pieces of equipment live, I had this sitting over there too, which answers these last two questions. We'll go over them right now. Question 25. Why is distilled water the only water used in the chemistry lab? All right. You can use tap water to rinse a beaker out or whatever, but as far as using water as part of a chemical process, or using water to clean out a beaker in its final cleaning, we use distilled water only. Reason being, distilled water is purified. It has no chemicals or contaminants in it. Tap water does. All right. It's got lots of stuff in it. Good stuff that we need for nourishment, obviously. It's got minerals in it and other things dissolved in it that are very useful to us. But in regards to a chemical reaction, some of those minerals or chemicals that are found in tap water could interfere with your chemical reaction. And so for that reason, we only use distilled water. Distilled water is like 99.99% pure. Okay? And then the last question, 26. What are Mr. Keister's three most important safety rules for the chemistry lab? I mentioned this yesterday, but if you look back there on the wall and you see to the right of the safety shower there's a poster back there with a horse. I got to walk back and show you this thing. It's cute. All right, so here we go. There it is. All right, so no horseplay in the lab. We talked about this yesterday on the safety thing. And the horse here is obviously playing, and he's doing all the things that we're going to talk about here in question 26. So what are my three most important safety rules? Number one is wear your goggles, of which the horse is not. He's protecting his forehead rather than his eyes. That's a big no-no. Number two, no horseplay, which is exactly what this horse is doing. He's playing. He's really busy playing. He's squirting a water bottle. He's throwing paper airplanes. Wow, this guy is not someone I want in my lab. And number 3, which he's also doing inadvertently while he's breaking stuff, don't mix chemicals without permission. You don't want to do that because you don't know what you're making. Now, sometimes when you do that, nothing might happen. Another time you would try that, and we might be clearing the room because we've made a poisonous gas, or worse yet, we've produced a reaction that is extremely exothermic and gives off a lot of heat, and as such, it could explode. So, rule 3 then is do not mix chemicals without permission. So, number 1, wear your goggles. Number 2, no horseplay. Number 3, don't mix chemicals without permission. So that takes care of our practice quiz. Hopefully now you understand what everything looks like, what it's used for, how to use it. And again, we'll be having a quiz in Canvas over not only this stuff, but also the lab safety stuff that we talked about yesterday on this coming Monday in Canvas. So until next time, this is Mr. Keister. Stay safe, and I'll talk to you soon. So long.